In our last lesson, we talked about why someone might say that 27 hundredths has a greater value than 5 tenths, because it has more digits. And with whole numbers, that makes sense. But with decimals, they behave a little bit differently. To understand why 5 tenths is actually greater than 27 hundredths, we're going to look at the model and then also the fraction. So if we shade 5 tenths, each of these bars represents 1 tenth. We can shade in 5 of them and see that half of our figure is shaded. When we shade 27 hundredths, we know that that's the same as 2 tenths and 7 hundredths. So we're going to shade 2 bars or 20 pieces and then 7 more, 7 hundredths. Okay, so we can see in the model that 5 tenths is greater than 27 hundredths, but we won't always have a model and we don't want to draw a model. So yesterday we looked at fractions. 5 tenths, 27 hundredths. If I use equivalent fractions, I can see that 5 tenths is the same as 50 hundredths. And so that makes sense why 5 tenths is bigger. But sometimes we aren't going to want to write the fraction out either. So today I'm going to show you a quick way to do this in 2 easy steps. Step 1 is to stack them. And step 2 is to add zeros. And let me show you what that looks like. If we line these up vertically so that our decimals are lined up, the places will also be lined up. We have ones, tenths, hundredths. We're going to add zeros to any places that are missing. So for example, 5 tenths doesn't have a hundredths place. We're just going to put a 0 there to show that there's 0 hundredths. Now these numbers are lined up and they're balanced, and it's easy to see that 50 hundredths is bigger than 27 hundredths. Let's try a few more examples where we skip the model and skip the fraction and just get right to the decimal. Which is greater, 88 hundredths or 127 thousandths? So my first step is to stack these decimal numbers. 88 hundredths, 127 thousandths. We make sure that our places and our decimals lined up. So we have ones, tenths, hundredths, thousandths. Where do I need to add a 0 so that this is balanced? If you said my thousandths place, you got it. Now remember, this 0 has no value. It is not changing the value of 88 hundredths. It's simply showing that we have no thousandths. Then it's as simple as saying, okay, 880 or 127, because they're both thousandths at this point. And it's clear that 880 is bigger. This strategy works for ordering decimals as well. If I have 4 numbers, I can stack all 4 of them and just balance them with zeros, and I'll be able to order them from least to greatest. So we're looking for the smallest number to the biggest number. Let's get started. We're going to stack 2 tenths, 33 hundredths, 25 hundredths, and 111 thousandths. Ones line up, tenths line up, hundredths line up, thousandths line up. What's left for me to do? I'm going to add zeros to the thousandths place for these two, and I'm going to add hundredths and thousandths to this one. The value hasn't changed. I've just balanced these numbers so that they are all out of thousandths. It's like changing fractions so they have the same denominator. Then it's really easy for me to just look and say, okay, which of these numbers is the smallest? 111 thousandths. I'm going to cross that one out so I don't use it twice. Up next we have, I'm going to go back to the original form of the number, which is 2 tenths. Up next, 25 hundredths. And then my greatest number, 330 thousandths or 33 hundredths. Double check that we did least to greatest, because sometimes they will flip that and ask us to do it greatest to least. So make sure you read those problems carefully. Want the worksheet I'm using in this video? Click on the link below and get the full packet, including partner practice, 3 pages of independent practice, a challenge page for your early finishers, and an exit quiz. Thank you for watching and happy teaching.